Thank you. Thanks for everyone staying back for as we wind down towards the end of the day. In this session, I'm going to talk about how do we unlock the business insights in traditional analytical applications using natural language and generative AI. I am Vijaya Bashyam. I'm an STSM at IBM, and this is my colleague Neerju Gupta. She's a senior architect in the data intelligence platform. So we'll be talking about, I'll be introducing the business problem, what challenges we have today in the analytics field, and what sort of challenges that are, data steward versus a line of business user faces, and how a Gen AI model with text to SQL helps us bridge these gaps. And if time permits, we may talk a couple of use cases. So business insights. So what do we have? We have a lot of OLTP databases that has billions of records of data in mostly in a relational database of some form. It could be Oracle, DB2, MySQL, PostgreSQL. So there's like so much data available. So when we go and ask to provide some insights, it's always has to go through some sort of a back-end processes. Like, let's say, for example, a business user need to get, hey, can you find out, what was the last highest sale that I had for this product in this region? So, the data steward needs to go to the back-end, figure out what are the various queries that they need to form, and then come back with some analysis, and then sometimes it may work, and sometimes the business user would say, oh, no, this is not what I want. I want even richer data set. To manage to report it to my senior management. So what we are trying to achieve through this Gen AI model is to, once I define a data, and first of all, how do I define the data? How do I ingest the data? How do I create metadata out of that insights? And then once that data is in a structured format, how would I be able to discover insights in that data? So for example, I could have a table, say, all my order sales order information, which could have, what are the products sold, which region it was sold, and what's the revenue I achieved in that month based on the region that I'm running this business in. And let's say as a business line user, I want to find out, what's the highest sales for this region during, last year peak season, last year Thanksgiving. So how do I surface such insights within a, I want it within a few seconds, and I want it in a language that is easily understandable by the business user. And not only that, I also want the ability to share that question and answer in a natural language format, wherein I don't need to have an extra translator like a data steward who's going to sit between the business user and the product to make sense out of this. And another advantage that I'm also looking for as a customer is to ensure I want to make use of my existing infrastructure, existing data set. I don't want to go into another set of migration, moving my data from an unstructured to a structured format. So I want the ability to run any such insights on my existing infra and existing data sets. And we also want the ability to kind of distinguish between the persona of the user. When a data steward asks a question versus a business user asks a question, what sort of implementation that the backend AI need to understand to provide me better insights. So for example, a day in the life of a data steward versus a line of business user. Typically, I don't know how many of you have been in the role of a data steward. I myself have been acting as a data steward for one of my products, wherein we will be constantly getting questions from the business team saying, hey, I need this insights, go find out. So the amount of questions that come in from such, say, for example, particularly the sales team or the offering team who is like, field-based personas, is really too much. And it also kind of ends up with some repetitive work. And I would say probably 10 years, I would say 7, 8 years back also, we had this constant churn of work that needs to be done manually. And then we introduced this text to SQL technology and made sense for the data steward. How do I structure my data? How do I create metrics out of the data? How do I make my data more understandable for an end user? Those are the benefits I obtained after I implemented with text to SQL. Similarly, for a line of business user, they just want, when I ask a simple question, answer me simply, and then provide me a pictorial representation. When I ask you, show me the revenue of the last three months in this particular region, I don't want you to tell me, okay, these are the, don't give me some value, like dollar value of these numbers. Instead, show it to me in a graphical format, so I can probably use that. Let's say, for example, a VP or a director who doesn't have much time to make sense out of the data you show me. Instead, if you show to me in a pictorial format, it makes more visually appealing for me to make use of this product. So these are all some of the challenges we had and the benefits we achieved through the text-to-SQL mechanism. And now I'll let Neerju to kind of talk about what is text-to-SQL and how we are implementing it in the solution to make sense out of the various data models that we have.
Yeah, thanks, Vijaya. So, as Vijay mentioned, that we are trying to solve a problem for the business users, make it more self-serve. So you ask a question, it can give you the insights right there. You don't have to go to the data steward and put a request and wait for the days for getting those insights, right? So that's the advantage of these. You give a natural language question, it returns you a SQL query back, and you can take the SQL query and run it, right? So that's essentially what text to SQL is. Everybody is familiar. I'm sure you have heard about it, right? Now, what we are going to discuss here is how do we do it. The SQL, most of us are familiar. It's a very formatted structure. If you see a structure, if you see a SQL, it has a select clause, then it has from, where, right? Any large language model, today you ask it a question, they are trained and they are able to generate a SQL pretty accurately. But the challenge lies in that when you have large amount of columns, large amount of tables, how do you provide that information to the models so that the generated SQL is actually executable? It understands your data, it understands your column name and your table name, right? Because if you see in this structure, model knows that the question has to be returned somewhere like, okay, select order from some table, right? But that column name, that table name, what exactly is that order, the table name or column name in your data source? How do we give that information to the model so that your SQLs are correct? That's the real challenge, right? The challenge is not creating the SQLs, challenge is to give that context. And that's what we're gonna talk about how we do it. So what we have done is first of all, you have like in our enterprise customers, we have seen that they have millions of tables, right? They have hundreds and thousands of tables and columns, and they don't want to move their data, right? They don't want our system to connect to those tables live. So what we do we have the phase called the preparation, where we connect to the data source and we catalog the metadata from these tables, right? So we bring this table and column metadata inside our data catalog. Now, when we started doing it, the other challenge what we saw, that these table names or column names these are traditional, maybe 20 years old tables and columns. These were created in a very cryptic acronym fashion. And when we are trying to use the technology to find these, it was not clear, right? So I'll give you some examples, but these cryptic names were still not very useful. So we need to, in order for models to make sense of these, we had to attach some context to it. We had to attach some descriptions and give more context to these so that our models can understand what these tables and column names mean. And we use some more models, so we'll go through that deep in that. So we take the model, column names, table names, we catalog it, we expand it using the models. And then the other challenge was that what Vijay was saying, a business user comes and they ask a question. They're going to ask a question in their business domain, in their business language, while all the metadata we have saved may be very technical in nature, right? So how do we translate that business context, the business, how do we map that business question to the metadata so that we can serve, we can answer that question accurately? So before we even go to the actual retrieval part, we had to prepare this. We had to give this business context to our metadata. So that's the another step in preparation, that we were assigning the business meaning to the technical metadata so that we can query these, right? So these are all the steps as the preparation. Now, in a SQL, when you say, okay, select star from table X, and then it comes to the joins, right? Now, in order to efficiently join, the model needs to know what are your foreign keys, what are your primary keys, so that we can give that information and then the model can make use of it. So we had to analyze, we don't want to collect it live. So we collected that information and we are cataloging those relationships between tables, the columns, and keeping it in our catalog, right? Another interesting challenge was that there is where location equal to something. So now that comes to the data part. That comes that how you can say location is US, location is United States. It can be written differently, right? So we need to understand in any database what that, how is your data structure? What is the information? So we started looking at that problem, and what we do, we profile your data and we capture some formats so that we can then provide this information to the LLM and it can give that filters or content filters accurately. So these are all the preparation steps. Once we have done the preparation, we have now cleaned up the data and then we vectorize it and make use of this metadata, right? So let's take a deeper look into how we do it, some of these things. So just this is an example for a real world example, right? We have these tables. If you see the first column here, these columns, if you are looking at it, it will probably not make any sense to you. Now, if I'm giving these column names to my, first of all, it's difficult to find these column names with some searches, with some natural language searches. Secondly, let's say if I do give these column names to the model is not going to make any sense of this because these are very domain-specific names. So our first step, what I talked about, is what we did. We took this model, the names, we cataloged, and then we used another model with the knowledge of the business domain to expand these column names to more detailed, more descriptive names, and also gave more descriptive information, the descriptions to these. And this is where it enables us to now search this metadata using the natural language, right? So this is the architecture diagram on how it looks like. So this is an example, like if the technical metadata is like this, we took a large language model and we provided it some sort of minimum, like the domain-specific acronyms, the business glossary as the context, and then we use that model to expand these column names in a more accurate and descriptive fashion. So this is our first step of preparing the data. We are giving these more full names and descriptions. Then the next step is that once we have the names and descriptions, this is still like, okay, employee ID, communication ID, plant and date, right? But what I talked about, that business users may ask a question which is more business language, like they may ask a question on communication, what is my, when is this communication expected to be, to end, right? Now this doesn't match or map one-to-one when the natural language question comes. So we want to attach that business meaning to these columns so that these can be discovered when a business question comes. So what we did is we took these names and descriptions, and then we started vectorizing it. And then we use the similarity search, the cosine search, to map the business meaning to these metadata. So now we have technical metadata, we have the full English names, we have the description for these technical metadata, and as well as we have a business meaning attached to this. So this is all the different phases of what we call the metadata enrichment or preparation before we even go to the text to SQL step. Right. So you can skip this. So this is all the preparation, right? We connect to the data source. We ingest that metadata, bring those metadata in, and this is the only step where we are actually connecting to the database. This is one time your ingestion step. After that, you have your metadata ingested in the catalog. We don't need a live connection to generate these SQL queries. And that is very important for the enterprise customers, because the enterprise customers and the production level, they don't want you to connect to their data sources when it's the business hours, right? So they don't want you to have any live queries running for this purpose. So we only ingest this metadata once. Now we have the metadata, and we start our enrichment process. We use the models as I described to give the business meaning, to describe this metadata. We analyze the relationships, which is also captured as part of our ingestion, like foreign keys, primary keys, we catalog those. And we then have these sample values, which is collected as part of our ingestion, and then we store it and also have the relationships associated with this. All this information is captured, and then all information is vectorized and saved in the vector stores. So this is the first or the series of steps which we take to prepare our data before we can start talking to this metadata and start asking questions, right? So now the hard job is done. Now we have all the information we need. It's all vectorized, and this is now ready for us to be used. The next step is really easy. So we have, when a natural language question comes, when a business user asks a question that, give me the orders information, we just go and we take that question and we search our vector store. We do the keyword searches, we do the semantic searches. There is sophisticated algorithms here because we do these hybrid searches, and then we do the ranking and re-ranking of these searches to find the most accurate or most relevant columns for our use cases. And this is important. There was a session earlier in the morning for this, where it was about the RAG, that how RAG is not easy, because in order for RAG to function, it's very important that you give the context to the model, and you give the right context, you give the more concise context, and you don't overboard the model with a large context, right? And that is the problem we have solved here. We had 100,000 or more columns. We cannot give that many columns to the model. We have now pruned that because we are now matching and finding out the relevant columns and giving it to the LLM. So now the job LLM has to do is easy, because it doesn't have to now differentiate and find out the relevant columns. All it has to do is it has to take this 20, 30, or maximum 40 columns or few tables which are relevant for this query, and then just work on generating the queries, right? So we are only focused on, can LLM now generate the complicated queries, the SQLs in this correct syntax, which can be executed. But LLM doesn't have to. There is no chance or less chance of hallucination. It's not going to result in some random columns which do not exist. It's bounded with those columns or context which is provided to it, right? So we take these metadata, re-rank it, give this information with all the relationships to the model, and then model is able to generate those queries. So this is how it looks like. when the natural language question comes to our service, we use an embedding model. This is the Slate model hosted on watsonx from IBM. And we take that, we create the vectors out of it. Then we go through this part of schema linking, where basically we run these different types of metadata searches, the keyword searches, we run some data searches, and then we do reciprocal ranking or re-ranking of returned results based on our business requirements, right? So all these searches have some weights attached to it so that we can find out the relevant, what is the most important columns for us. Once we have that, then we take the results and we run it through the other part we talked about is the content linking. So the part where content linking comes into picture is that you have what I was saying, where location equal to US or United States or something. Now we have to create different types, different combinations of that data because we don't exactly know how the data is structured. But what we have done is, because we have captured the format of the data from as part of our preparation, so we take that format, we give it to another LLM based on the query and ask it to generate different types of clauses for fulfilling this request, right? So now we take those, and LLM, because it knows the format, it is mostly able to do a very good job in generating the clauses for that. Now we take these, we combine this information, and then we finally give it to our text-to-SQL models, again running on watsonx, to create the SQL queries with metadata information, with the clauses, with the relationships and all, and then we take that SQL, score it back, and return it back to the user, right? So that's the overall process. So there is one process which is offline, where you are preparing the data and making everything ready, and then for the business user, the things are ready. All it simply asks a question, it performs this complicated searches, and it's able to generate you the accurate SQL back. So this is how it looks like, a very real world example that if the simple question is asked, you see the query is quite complex, which came back, but it is actually driven from the actual table names and column names. It's not some random hallucination from the model, which is critical for the enterprise users. They can take this query and then execute it directly, right? So this actually serves the self-serve model about taking the information and executing it directly. They don't have to wait for data stewards for providing them these kind of queries, right? And the other thing, what in the business use case, if they want to tweak it, it's just a matter of seconds now. If they don't like this query, they want to add another information, another column, or they want to change this, they can just ask another question, and we can generate them the new query in matter of seconds. So think about it, something which was taking days for a business user to put a request, that request has to go through the approval, then the data stewards have to act on those requests, formulate the queries, go back to the business user. Maybe the business user is again not satisfied, raising or erasing the request, and there was this cycle which is going back and forth. That time is reduced, right? So it's a real business value for our users with this kind of technology. Okay, so this is just the summary of like what are the critical components we just talked about. What the first part, which is the heart of the this entire discussion, is that the schema linking. We really need to know the context which we can send to the model, which is the column names, the table names, and in the language which makes sense for the model. We cannot just take the original technical names and send it to the model. And then what are the relationships and all that? That all comes under the schema linking part. The other, if you see this example, the other thing which we added is that every business has may have some special instructions, right? So we added this capability that if users want to give some special instructions, the business instructions, we can give that as additional instructions to the model. So that is taken care by the model that, okay, if there is anything additional. So, and then we build the prompt. We have the content linking where we generate the different clauses using the model. So all these are the key components. We also have added support because what we have seen is the models do extremely well when you give it the examples. So let's say if the business user have now interacted with this system, they have come up with some queries after few iterations and they are satisfied, they can give that feedback. And now that feedback is then we save it so that next time when a similar question comes, we can give those kind of examples to the model that when you are when this kind of question comes, this is the query which is expected. And this really helps model in further accuracy in leveraging those examples and giving the even more accurate results back. So all that is built in the system. And then there is the SQL evaluations and scoring and giving those back to the user. So I think those covers. Yeah, so those are the technical insights. What are the models we are using here? So we have, so in this process, if you see, we started with metadata enrichment. So we use large language model to enrich the metadata. Those are the Granite 8B model hosted on watsonx, which are used for metadata enrichment. And then for text to SQL purpose, we use the Llama model, which is again hosted on watsonx, and we use that for the generation of the SQL. And then we have the embedding models for generating and embeddings or vectors and storing it. Right? I think that's it, but we have 10 minutes, or we can have the question answers or go through some of the use cases.
Yeah, go ahead.
Yeah.
Thank you. Great talk. So I had a few questions. So first of all, when you're doing the metadata enrichment, right, you're trying to extract names of columns. There are cases where, depending on the context, you'd have completely ambiguous column names, things like total 1, total 2, total 3. Maybe they are logged in different times. Maybe they're logged in different systems. Then they got aggregated, things like that. How do you handle that?
Yeah. Yeah, that's a good question, and we do have those kind of challenges. What helps there is this, what I showed you, the custom instructions, right? So that's where you can specify that, okay, these, when I'm asking this question, there are, because as a user, if you know that I have this kind of data which may not be normalized, which may not be perfect, you can give that as a special instruction that, okay, total 1, total 2, total 3 all represent like this column, right? And that is why this feature was added. And actually, we have this feature very heavily used in watsonx or data, where the data is coming from different sources, and this really gives value, that giving those instructions.
But in a large table structure, when you have like a lot of these column names, imagine when you have 100 tables with 100 columns each in them, you can't possibly go through every single table and every single totals or these kind of ambiguous things. So in a scalable format, how would you handle this? Or is it going to have to be manually mentioned?
So there are two things, right? One you said is at the time of preparation. How do we prepare it, right? So obviously, model is going to say everything is total, right? And now what we do is now that total, one is that, okay, in which context that total is coming. Is it the revenue total? Is it the orders total? So we do take that in context when we are giving the descriptions. We do take what is your table name and column name. So we do take that in context. The other is, let's say if you had, you don't have that at the preparation time, that's when I was saying you can give that custom instructions, and that is at the business time you can provide those. So there are ways to do that.
Got it.
Yeah.
So you also mentioned United States versus US when it's ambiguous column values themselves, like row values.
Yeah.
Maybe in one situation, it's like process 1 is generating US, process 2 is generating United States, and it's being aggregated into this one table.
Yeah.
So in that case, when a user asks for United States, do you like consider both the values? Do you consider one of them?
Yeah.
How do you handle
Yeah,
that?
absolutely. Yeah, that's one of the bigger challenge, honestly, because we don't want to index all the data, right? Data is much larger than the metadata, so we don't have that. But what we do have is when we analyze the data, we extract the formats, right? So I'll give you another example, like column like CCE. It may credit card numbers may has a very good format, right? Phone numbers have very good format. So now when we give this, or even in the US case, let's say country, it's a country equal to US or country equal to United States. We give that format that most of the values contain, the most format is whether it's a 3-digit number or whether it's a string. So the model now knows that whether it has to produce the code or whether it has to produce the actual value, right? So that's one way of optimization. But then we also, because we use another model for creating those clauses, we also get multiple clauses like country equal to US or country equal to United States or country equal to United States of America, right? So we do take multiple and or them together to some extent. So there are ways for those further optimizing those things.
Got it. My final question is regarding the retrieval time. So imagine you have written a great SQL statement, you've got the table values, maybe it's 50 columns, and you have, after the SQL statement executes, you have maybe 100 rows that comes out of that. This data can be more than what the context of the model itself would fit. So how do you handle answering a user's question in natural language when you can't provide the entire SQL's returned data to the model?
Okay, so important distinction, right? Text to SQL, we are returning the SQL back, right? We are not executing the SQL for two reasons. One, what you said. The other is enterprises, as a business user, don't want to execute that SQL directly, right? Because it's a production system. They want to take that SQL and maybe they want to create a report out of it later, right? So we are giving a SQL which you can execute in a governed fashion on your system. This service is not returning that SQL.
But how do you do that without data stewards then? You mentioned you're skipping the data stewards.
Yeah, we are returning the SQL back, SQL query back to the business user. They take that. Now, obviously, we have an application on top of that where they take this and they can execute it in the data source. That's the system, right? That's the entire product. But from the service point of view, we want to be your database agnostic. We don't want to connect live to the database because nobody gives you access for that, right? Only the business user takes the SQL back, they punch in their credentials, they execute their SQL. So that's the layer on top of us.
Got it.
And
Thank you.
sometimes in financial situations, they would not even give us access to the data source.
Right.
So we may not have access to the data source, but we can still provide them the SQL, and the customer would have a different portal through which they execute and visualize the results.
Got it. Thank you.
Any other questions?
So for each new SQL database, do you have to do the metadata enrichment every time? And then if you do at this point, do you have a rough time estimation it takes for like relative sizes of these databases?
Right. So it's only one time, right? So you connect to your database once, which we call the preparation step. It's called data cataloging. So you connect to it, you ingest your metadata and enrich it. It depends on how many tables and columns are there. Typically, I think if what I have seen is like 1,000 columns, even with the large language model enrichment, it takes about like, I think 10 minutes or something like that. It doesn't take, and that's also we are using the quantized models. So it's not too much time processing. The most amount of time it takes is the DB queries where we have to analyze the data, actual data, and that depends on your database performance, right? But again, it's all one time. It's done once, it's cataloged once, it's there in your metadata catalog, and then that's it. You are not running any live queries. So whatever is the idle time, that's where it is done.
Thank you.
And if you have any customer, and let's say you are adding additional columns or data, you're extending your database tables, then you can do a delta
Delta.
into the application, so that way it captures just the differences and prepares that for future queries.